This is a lesson on Newton's laws. I'm going to do what's called flipping the classroom, which means typically in a traditional educational situation, I would lecture in class and then give you problems at home, which means you probably get the lecture in class, you get home, and you struggle with the problems. So in this one, we call it flipping the classroom. I give you the lecture at home when you just have to copy down what I say, basically. And then you come in the next day, ask any questions that you have, and then I can help you with problems in class when you need the help the most. So, what we want to talk about today is Newton's laws a little bit. Now, Isaac Newton, you've probably heard of him before. He had 3 laws of motion. Today we're going to talk about 2 of them. One of them you read about in your reading. Hopefully you've done that already. I'm not going to reteach that in a formal sense, so make sure you understand the reading. But I will talk about it a little bit in class here and there. What I want to focus on mostly for this lesson is Newton's second law of motion. And this is what we get from our lab. So, if you remember from lab, or if we have those lab handouts and your graphs and so on handy, you found 3 relationships. And the first relationship that you found looks something like this. Acceleration is proportional to 1 over mass. In other words, they are inversely related. As the mass went up, the acceleration went down. The other thing we found was that the force was directly proportional to the acceleration. Again, here as the force on the string went up, it pulled the cart harder, and the acceleration went higher as well. It was a direct relationship. Thirdly, we put all these together in one graph, and it looks something like this. That was the final relationship. F over A is proportional to the mass. And when you look at those 3, you can combine them into one statement. And that statement combined would look like that. Or another way to say it, in fact, we know that it's not only proportional, it's equal. So that F equals N times A. That is a very important equation, the most important equation we'll deal with all year. In fact, this is the one equation that I require you to memorize for the entire year. Now, this law then tells us something, and I'll state it like this, because while Newton had math, he did not state it in his famous book in this way. He stated it like this. The acceleration of an object is directly proportional to the net external force acting on it, and indirectly proportional to the object's mass. I'm going to say it again, but I'll remind you here that you're watching a video online. You can always pause something or go back and watch it again if it didn't make sense the first time. Here it is again. This is what Newton said. The acceleration of an object is directly proportional to the net external force acting on it, and indirectly proportional to the object's mass. Now, I'll ask you tomorrow and show you tomorrow what I mean by net external force. But basically it comes down to this equation. And Newton called that, or it came to be known as Newton's second law of motion. His second law is simply an equation. That's it. His other laws, as you know from your reading, are more conceptual than mathematical. Now, one thing I want to talk about with this, and that is the units for forces. So, we know that masses are measured in kilograms. In physics, we always measure mass in kilograms. We know acceleration is measured in meters per second squared. So the units for force would be kilogram meters per second squared, but because that's so long and kind of annoying to say, we've just renamed it in honor of Isaac Newton. So now we call this 1 Newton. So that 1 Newton equals 1 kilogram meter per second squared. That's Newton's second law of motion. Don't forget to do your reading for tonight. Again, I will not reteach on that. Here's the lesson on Newton's second law. I'll demonstrate a little bit of it tomorrow, and we'll do some other things in class as well. If you want to know how well you understand Newton's first law of motion, which is from your reading, you may want to check out page 42 and do numbers 22, 31, and 33 tonight. Good luck. Let me know if you have any questions tomorrow.